All right, this is Module 1, Lesson 12. We're going to take that idea of unit rates and constant of proportionality from yesterday, and we are going to apply it to more scale drawings. Example 1, Jake created a simple game on his computer and shared it with his friends to play. They were instantly hooked, and the popularity of his game spread so quickly that Jake wanted to create a distinctive icon so that players could easily identify his game. So he drew a simple sketch. From the sketch, he created stickers to promote his game, but Jake wasn't quite sure if the stickers were proportional to his original sketch. So we're talking about that idea of proportional. Remember, proportional means that all the unit rates are the same. So all the sizes would be increasing at the same rate. So if this is his original sketch, this is the sticker. You notice that it is getting bigger. The sticker is bigger than the original sketch. So we call this an enlargement. Now, if the sides do not go up at the same rate, what's going to happen is it's going to distort the image of the sticker on the sticker. So we want to make sure it is proportional. So we're going to line up the original sketch to the sides on the sticker and see if those are increasing at the same rate. So if you look at the sticker, we have this side right here that says 7/8 of an inch. At 7/8 of an inch corresponds to this side right here. It means it lays in the same spot. That's 1 3/4 of an inch. The one down at the bottom here, this diagonal, would be 0.75, and that corresponds to this one right here, which is 1.5. Now this side right here is 1 inch, and it lays right in this spot, which is 2. And the one in the back is 1, and it corresponds with 2. So let's find the constant of proportionality. Remember, K can be found by doing Y divided by X. And when you have a table like this, this is your X column, this is your Y column. So we're going to take each one of these individually, and we're going to divide it to see what the rate of increase is. So for the first one, the Y value is 1 3/4. The X value is 7/8. So we're going to divide that. 1 3/4, you can use your calculator, divided by 7/8, and that gives us 2. Now let's do this one right here. We have 1.5 as our Y value, 0.75 as our X value. So when you divide that, you get 2. The next one is 2 divided by 1, and we know that's 2. And the last one is actually the same thing. So notice that every time you divide, you get 2. So the constant of proportionality is 2. Now, if that means that all the sides are increasing at the same rate, the sticker would be proportional to the original sketch because the unit rates are all the same. So we have this idea called scale factor. It says the scale factor can be calculated from the ratio of any length in the scale drawing to its corresponding length in the actual picture. So basically that's our constant of proportionality. So what is the scale factor? In this case that we just did, our scale factor is the same thing as the constant of proportionality, which would be 2. So this is our scale factor. Now, basically what that means is that everything is doubling or getting larger at 2 times the rate. Next page. So let's talk about this idea of how to check for proportionality from scale drawings and original objects. All right, the first thing we're going to do, this should actually say 1. We're going to take 3 steps, 1, 2, and 3. Step 1, we're going to measure the lengths. of the scale drawing. And we're going to record that in a chart. Now, sometimes they'll already be measured for you. You just have to record them. Step 2 is going to be measure the corresponding lengths. Of the actual objects. And then record in the chart. Once again, sometimes they'll already be measured for you. You just have to record them. And then the last one is just to check for proportionality. Are the unit rates the same? All right, so let's go back to the key idea here, that the scale factor is calculated by the ratio of any length in the scale drawing to its corresponding length in the actual picture. This is also the unit rate or the constant of proportionality. The idea of finding the ratio would be called the constant of proportionality. Now, if scaling factors are greater than 1, that tells us that we're enlarging the picture. If it's less than 1, that means we're reducing it. So I keep telling you, the last one was a scale factor of 2, meaning it was doubling in size. It was getting bigger. If a scale factor is 1/2, that means that it would be getting smaller, becoming half the size. All right, I'm going to have you pause this video because I want you to try exercise 1 on your own. Same exact thing that we did on the first page. Setting up a chart. You're going to find the constant of proportionality and the scale factor and tell me if it is indeed a scale drawing. So pause the video, try it on your own, and then hit play to see if you are correct. All right, so in the chart, we should have the original drawing versus the app icon, which would be the scale drawing. Now you're going back to the picture on the first page. So on the first page, if you look at this side right here, the original drawing was 1, but in the app icon, it's 1/2. Go back and look at the first page again. This side was 1, but in the app, it's 1/2. This side down here in the original drawing was 0.75, and now it's 3/8. This side over here in the original drawing was 7/8, and now it's 7/16. So let's find the constant of proportionality, y divided by x. Remember, original is x, app is y. So the first one is 1/2 divided by 1, which is 1/2. Next one is the same exact thing. 1/2 divided by 1 is 1/2. Next one is 3/8 divided by 0.75. So take your calculator. 3/8 divided by 0.75 is 0.5, which is the same thing as 1/2. And 7/8 divided by 7/16. Oh, I did that backwards. It should be 7/16 divided by 7/8. Y goes on top, X goes on the bottom. So 7/16 divided by 7/8 is 1/2. So the constant of proportionality is 1/2. So what is the scale factor? The scale factor is 1/2 as well, because that's what the constant of proportionality is. And because it's 1/2, that means it's becoming half the size, which is a reduction. All right, next page. All right, the next page says, is the app icon an enlargement or reduction of the original sketch? All right, that actually goes along with the question that we just did, which was the reduction that we just talked about. All right, example 2. Joanna wants to create a drawing of the Colombian flag shown below, and she uses a scale factor of 3 to draw the scale drawing on the flag. Will her drawing be an enlargement or a reduction? Well, if the scale factor is 3, that means it's being enlarged. It's actually tripling in size. So if the dimensions of the flag are 1.5 by 1 inch, what would the dimensions of the drawing be? Well, if it's tripling in size, that means that everything is being multiplied by a rate of 3. So 1.5 times 3 would be 4.5 inches. And 1 times 3 would be 3 inches. So the new dimensions would be 4.5 by 3. All right, so exercise 2, if she uses a scale factor of 1/2, is it going to be an enlargement or a reduction? This would be a reduction. So what would the dimensions be? Well, this time it's decreasing in size by 1/2. So we can take those dimensions, multiply it in half. So you get 0.75. And then 1, if you take half of that, is 0.5. So the dimensions are 0.75 by 0.5, and that's still talking about inches. All right, example 3. Your family recently had a family portrait taken, and your aunt asks you to take a picture of the portrait using your phone and send it to her. If the original portrait is 3 feet by 3 feet, the scale factor is 1/18. What would the size of the portrait be on your phone? All right, I'm going to actually set this up like we did earlier with the original chart and the new drawing, just so you can see it looking like this. This is 3 feet by 3 feet. So we have 2 dimensions here. And the scale factor is 1/18. So if I take 3 and multiply by 1/18, I get 1/6. That's still feet, 1/6 of a foot, because you're already in feet and it stays as feet. 1/6 of a feet, we don't normally hear it like that. Since there's 12 inches in a whole foot, 1/6 of that would actually be 2 inches. That would be a more common way of hearing that. Same thing, since that's the same dimension, still would be 2 inches. But you get that by still multiplying by that scale factor. Your problem set is following this lesson. Try out those answers and we will check them in class tomorrow.